In this last section, I'm going to be talking to you about perfect squares. Perfect squares, you just factor them like any other trinomial. The thing is, once you get your final factors, they're going to match. And so, like, you could have x minus 2 and x minus 2 so that you can make x minus 2 squared. So if you want to pause this and read about perfect squares, you can. And if not, move on to the next slide. So in this problem, we have a factor x squared minus 8x plus 16. So we're going to factor the same way that we have been in this chapter. We're going to say what times what gives us x squared, x times x. What multiplies together to give you a positive 16 that adds together to give you a negative 8. Well, that would be a negative 4 and a negative 4. Because negative 4 plus negative 4 is negative 8. Negative 4 times negative 4 is positive 16. Now, the thing about this section is why it's called perfect squares is because these are exact same thing. So you can write x minus 4 squared because you have two of them, and that's it. So in this next problem, we have factor 6a cubed b to the fifth minus 15a squared b. So you want to look at your greatest common factor. So what number can go into both 6 and 15? 3. Okay, now how many A's do each of these have at least? They each at least have 2 A's. What about B's? They at least have 1 B. So what do I need to multiply to 3a squared b to get 6a cubed b to the fifth? What do you need to multiply to 3 to get 6? 2. How many more A's do I need? I need 1 more A. How many more B's do I need? 4. Okay. Then I'm going to carry down that minus sign. What do I need to multiply to 3 to get 15? 5. How many more A's do I need? None. How many more B's do I need? None. So this is it. That's as far as I can go. This is not a perfect square. It's not the same thing. So that's all that I can do on that one. In this section, what you'll see is you've got many different kinds of factoring problems all in the same section. So it's kind of like a review of all factoring put together. So what do we remember from all factoring problems? You factor out the greatest common factor first. So what can I factor out of all these things? 2. I can factor out a 2. I would be left with 5x squared plus 12x plus 4. Okay, so now we have a trinomial with a quadratic term in front. So I'm going to do this the way that, not guess and check, but the regular way. All right, so we're going to look at these two numbers. So 5 times 4 would give me 20. So what two numbers multiply to give me 20 that add to give me the middle term of 12? So what would that be? What two numbers multiply to give you 20, 10, and 2, and add to give you 12? I'm going to separate this. 5x squared plus 10x plus 2x plus 4. Remember that the 10x plus 2 is replacing the 12x. Okay, and then from this point, you're going to break it up because it's a quadrinomial. So what can I take out of this first set of parentheses? I can factor out a 5x. That's my greatest common factor. What do you multiply to 5x to get 5x squared? X. What do you multiply to 5x to get 10x? 2. What can I factor out of this second set of parentheses? So 2x plus 4. Both of those have a 2. What do you multiply to 2 to get 2x? X. What do you multiply to 2 to get 4? 2. Okay. Now, as you remember, you write, remember these parentheses match. So I'm going to write that in one parentheses, and everything else that's outside of the parentheses, the 5x plus 2, I'm going to write together, and that would be my final answer. You could do this problem with guess and check if you wanted to also. We can do that in class if you would like to see it. This problem, we are going to be solving the following. Q plus 2 squared equals 25. Now, what is the opposite? Okay, here's the deal. I'm trying to get the Q by itself, right? That's what I'm solving for. I'm solving for the q. So I need the q isolated. So what's the opposite of this square? We would take the square root. And what we do to one side, we have to do both. The square and the square root are going to cancel each other out. So I would just get q plus 2 equals, now what's the square root of 25? Well, 5, but also negative 5. So I'm going to put positive and negative 5. So you're going to get the q by itself. You subtract 2. Watch what happens. You've got q equals negative 2 plus or minus 5. Now, a lot of students like to set this up in two different ways. You can if you want to. It doesn't matter to me. You can go plus 5, which would give you 3, and q equals negative 2 minus 5, which would give you negative 7. So the actual answer is q equals negative 7 and 3. This problem you can solve two ways. You can just solve it, like I'm fixing to show you with the fractions, or you can get rid of the fractions. It's your choice. All right, so let's do this. Can we take out anything? No, we can't. So what times what gives you x squared? X times x. What times what gives you 1/9? Now, I know this seems a little confusing, but let's just do one number at a time. So what times what gives you 1? 1. What times what gives you 9? 3. Now, this is a positive, so we need the same sign here. This is a negative, so both of these have to be negative. Let's just check to make sure. Okay, so x times x gives me x squared. Negative 1/3 times negative 1/3 gives me 1/9. And I'm using guess and check here in case you didn't know. That would be negative 1/3 x if I multiplied those together. This would be negative 1/3 x if I multiplied those together. If I added negative 1/3 minus 1/3, I would get negative 2/3 x. Since this matches my linear term in a problem, that is correct. But again, this is not my answer because I'm solving it. So if I set these up, because the first parentheses and the second parentheses are the same exact thing, I don't need to write it both times. I can just write it once. So if I'm solving for x, I would add 1/3 to both sides, and I would get x equals 1/3. And that would be my final answer. I wanted to show you this method that I just did. Now what I'm doing here, a lot of people don't like dealing with fractions, so I just multiplied everything by the least common denominator, and you can pause the slide and see how this works out. You would still end up with x equals 1/3.